Hi everyone, it's Ono here, and this is one more live stream of creative coding and machine intelligence. For those of you who are new, I'm Nono Martinez Alonso. I code live and I do things that have to do with using code for creative means and trying to break down machine learning and artificial intelligence algorithms to understand them and be able to use them as a developer or as a designer. And I also produce the Getting Simple podcast. You can listen to any previous episodes on the YouTube channel or on gettingsimple.com/podcast. I will remind you that you can like this video if you want to support the channel, and that you can subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. So without further ado, let's get started with today's stream. So last week we did live stream 88 on a side project that I'm working on. So we were looking at a library or framework called TipTap that is a rich text editor for the web. It's open source, and we were trying to extend it for creating a node parser application that allows us to type things and get data from those lines parsed. In this case, we were trying to make some sort of text-based calculator for expenses, right? Like the money you spend on things. And if we keep moving, I'll say you can submit questions about the latest episode or any previous episodes of Getting Simple at gettingsimple.com/ask. You can submit a video or a voice note, and I would encourage you to send video or voice because that allows us to include it on the podcast episodes and maybe even reply live. Okay, so now we're going to get started with a section that is what we're going to be covering today. That's called TensorFlow Signatures. So I'm going to make a quick intro for this section and we're going to get started. Hi everyone, it's Nono here, and this is an overview or a deep dive on TensorFlow Signatures. We're going to try to understand what they are and also use them in code. So we're going to implement some code and be testing how we can create TensorFlow functions, TensorFlow signatures, how to use the TF decorator, and how to export our model to TensorFlow Lite and use those signatures directly. All right, without further ado, let's get started. Okay, so we have here the signatures in TensorFlow Lite page. This is at tensorflow.org/lite/guide/signatures. You can browse to this website on tensorflow.org and inside of the TensorFlow Lite section. But TensorFlow signatures are not only for TensorFlow Lite models. We can see here TensorFlow Lite supports converting TensorFlow models, input and output specifications to TF Lite or TensorFlow Lite models, and those are called signatures. Those specifications or signatures can be specified when building a same model or creating concrete functions. Signatures in TensorFlow Lite provide the following features. They specify inputs and outputs of the converted TensorFlow Lite model by respecting the TensorFlow model signatures, allow a single TensorFlow Lite model to support multiple entry points, and are composed of three things. And we're going to zoom in here. The inputs, which map for inputs from input name in the signature to an input tensor. Outputs map for output mapping from output name in signature to an output tensor. And the signature key, that is the name that identifies an entry point of the graph. I think this is much better understood with code. So here there is an example that actually we can also go to as a Colab notebook or even view the source of this code notebook on GitHub. And this is going to be walking us through this example, how to run this code and what each of the parts mean. I think they have exactly the same content, so we could actually go directly and execute this in Google Colab Notebook and actually try to experiment with this code as we go, and that will allow us to also modify these things. So I'm gonna I've opened the Colab notebook, clicking here, and now the first thing I'm gonna do, I'm with my account, I'm gonna say save a copy in Drive. So we're gonna save a copy of this notebook. That way we can modify it and execute it and then keep it for later. So we're gonna do here signatures in TensorFlow Lite, and this is actually live 89. So in case you want to go to that, that would be at let's add a text block here. Nonoma live 89. This notebook was modified on live 89, which is gonna be at this URL. Right, so now you get that note, and I'll share this link later. Actually, so I don't forget, I'm just gonna copy the link right now, make it anyone with the link so you can access it. And I'll just copy that link on the chat. Signatures notebook, and I'll put it there, and I'll put it also in this links here. Signatures notebook. Okay. All right, so let's keep going. So here we see the documentation we read. You can see a table of contents here in Google Colab. We're gonna close that. You can open it back here, and we're gonna zoom in a bit so you can read better, and press that there. Okay. All right, so the first thing is we're gonna click here to import TensorFlow as TF, and make sure that we are getting a runtime reserved for this notebook, as you can see here. And once that turns green, we're gonna have a runtime. Our Python code is gonna run on the cloud. There's a backend there. And as you can see, this is now connected, and we have RAM and CPU. We're gonna make sure that we have a GPU runtime just to make sure that we can execute this thing faster. So the runtime is allocated once again. All right, so let's, we're gonna delete the previous runtime. We're gonna run this once more in here. And now we have TensorFlow. Good thing to do always is get some TensorFlow information. I have this snippet of code that I always put there, where we're gonna get the TensorFlow and Python version and what GPU devices we have available. So we're in TensorFlow 2.9.2, Python 3.7, and we have a Tesla T4 GPU. And we're just gonna put here a note that is gonna be inspect TensorFlow, Python, and GPU and Python versions and GPUs available. All right, and now we look at the sample model. So let's say we have two tasks, encoding and decoding as a TensorFlow model. Class model, so that's our model, and we have this Python decorator that is TF function, and the input signature is going to be float shape none, so this means that it can get an array of them, and it's going to encode those as TF strings as string X. Okay, and note that this variable is defined just to be more clear, but you could actually just return this directly here and delete this, and the code would work exactly the same. All right, so we're gonna step back. So we have an encode function that this is an encoding function that takes a list of floats and returns, so okay, encodes them as strings and returns them. And then here we have a decoding function that takes a list of strings, decodes them as floats and returns them. Okay, so encode and decode. So we can actually, let me actually bring the remarkable tablet. Okay, here we got the remarkable tablet. So what we're gonna do now, I'm gonna switch it on. And as we've done before, we're going to share screen and just see a more diagrammatic explanation of what we're doing, because otherwise it might be a bit confusing to understand these concepts here. And I want to make sure that this is really clear. All right, so we open the remarkable application and we accept the screen share petition here. And I'm gonna make sure I have the tool that I normally use here. Okay, great. Okay, so here we got the drawing board and what we have seen so far. So we have the TF function. So this is what's called a Python decorator. We're gonna see, we can take a look at a bit more about what that is. So Python decorator. So Python decorators, you can see that we've said we have one that is tf.function that is being used in here. So this is the decorator. And we can see that, okay, so functions. So you know, if you know about defining a Python function, right? We have different ways to do that. And if we go here to simple decorators, now that you've seen that functions are just like any other object in Python, you're ready to move on, see the magical video, the Python decorator. Let's start with an example. So we have my decorator, say we. Def wrapper, print something is happening before the function is called, print something is happening after the function is called, return wrapper, say we. So this actually wraps our function wrapper and does something before and after. To understand what's going on here, look back at the previous examples. All right, so as I always like to do, let's just see if we can try that really quickly with code here so we actually see. So we have a conda.python 3. So we're just going to do the add, so a and b, which is going to return a plus b. Okay, so we do add 1 and 10, we get 11. And next I'm going to do, so if we take a look at those decorators, to my decorator function, so we do def and then greeting decorator. We're gonna do here get the func, and here we'll see, okay, the wrapper func. Well, we don't get anything here, and we'll say, okay, print hello greeting decorator, and then we're gonna do func, right? So we execute the function, and then here we do bye bye. All right, and we do that and we return. So now what we do is we're gonna do here greeting decorator at 220, and then we call this and nothing happens. say we. Okay, so we're wrapping the function. So we need to say here add with greeting. So we're gonna redefine our function add with greeting. So we do add with greeting 250, and then non-type is non-callable. Okay, something we did wrong. Oh, return wrapper. So we actually need to return the wrapper. All right. All right, so we now do this again, add with greeting, and then we call add with greeting. Wrapper, blah, blah, blah. Okay, so our function takes arguments, so that is a bit harder. So the idea is, okay, let's actually just redefine add without numbers. So we just put return 10. Okay, this doesn't work. Let me actually write a file. So let's exit here. And we're gonna make a directory for today's stream, and then we're gonna do touch, well, actually nano decorator pi or touch decorator.py, and then we're gonna edit that one. Okay, so let's try to quickly rewrite what we just did. So if we do def add and we just return 1 plus 10, and then we do def my decorator takes a function, right? And then we return the wrapper, which we have to define wrapper, and then we print the A, B, and execute the function. Then here we do add decorated. We can say that this is my decorator add with this syntax here. Okay, so add decorated. Okay, let's execute this decorator.py. Okay, so this decorates that function, and we if we had like another function here that said def add to and say AB, how would we do this now? With that, oh, maybe that's it. Takes 0 position. Wrapper takes 0 position arguments, but 2 were given. Okay, maybe we just pass here this thing. A and B, missing 2 required positional arguments. Whose wrapper missing 2 arguments? Oh, okay, so maybe we cannot add it for this one. Okay, so the decorator, we could even do this thing here. Okay, So the decorator, when we called add2, is going to print it. So print operation. And what we're going to do is, so we have this decorator that is going to be print decoration, print operation. And we do here add2, print operation. Okay, and then what this does is that calculating, and then here result, and then here done, right? So if we do that, now we have calculating and then done, right? So we call this add decorated function because it's been decorated. This is what it does. And I guess we could do here print operation add decorated, no, okay. Okay, so we have this syntax here. So the syntax you can see in here means that we are actually passing our function inside of the decorator, and then we're redefining a new function. So we keep add2 as a separate function and then add decorated. So you can see if I do here print the result of 3 plus 3 is, and then we do add2 3 and 3, right? We actually get that there, right? The result of 3 plus 3 is 6. And we can still call 3 plus 3 with the add decorated function, and it will return 6, right? So we have the two functions. This is one way of doing it. So we redefine add2 by passing it through print operation as add decorated. The other option is that we actually do define a new function, add to decorated, add to auto decorated, let's say, and we say, okay, this is going to take also a and b, it's also going to return a plus b, but we're going to add here the print operation decorator. And now if we do call the function, it's actually going to already be decorated, right? So this is the last call. This is the first call, and we lose the possibility of calling this function without the decorator. And this is what's going on behind the scenes, right, on that decoration, let's say. All right. If you have if you have any questions, just pop them on the comments. Okay, so we have here Python decorators. All right, so we have this code here, and I guess we can merge this with on the repo or share this code somewhere. So we define a custom Python decorator, define a Python function, pass our function through the decorator, and then using this function, this function call is decorated, this function call is not decorated, and then we define a function automatically decorated, and here we just copy this. All right. Okay. Okay, so this is a sample of Python function decorators. All right, so we have this code here, and what I'm gonna do is I'm going to move this to Python decorators. So we just have that as an example, and actually I'm gonna copy that. Let me see if I can find the repos here. Okay, so for the live stream, yeah, and we're gonna push this there. So we're gonna copy that there, and we should just be able. Okay, so we just commit that. Cool. So anyone, you can go to the live stream and find that folder here, and we got that script. Okay, so let's do what we did before. So we're gonna add Python decorators sample script, and this is primer on Python decorators. Great. All right. So with that, let's go back to where we were. So now we're back to signatures. So I was here, I was explaining this TF function decorator, and I don't exactly know what the TF function decorator does. What I know is that it's, let's say, given by TensorFlow. And if you have a Python function that does some computation, this decorator will make it faster. It's going to use the TensorFlow library optimizations to perform math computation, and your operations are going to be faster than if you just have a Python function. And I guess that's something that we could verify, that we could take a look at, and that wouldn't be a bad exercise to. Okay, so let's keep going. What we have on this example that we were looking at, we're actually defining two functions. So we're defining encode and defining the decode function. And that actually, what those functions are going to do, we're going to go from a list of floats into a list of strings, right? So that means that these are not going to be floating point anymore. They're going to be stringified numbers. And what's going to happen in here is exactly the other way around. Is that we're going to have strings and we're going to go into actual numbers. So this is from float to string, and this is from string to float. Okay, so with this in mind, we can go here and see that those functions do what they do. We could actually go and just probably use those functions as they are here. So we can, so this is TensorFlow strings as a string, and we can probably simply do this here. So if we go to Python, actually let me enter the environment where I do have TensorFlow. So import TensorFlow as TF, and we could, wait 1 second, conda activate TensorFlow Python, import TensorFlow as TF. And now inside of this runtime, we're importing TensorFlow. So the first thing we could do is inspect the versions and the things that we have available as we did before. Okay. And we do have a device that's called Meta. So that's the device that we use as GPU. And we have TensorFlow 2.10 in this case. For Python, I'm not sure if you can do this here, if you can actually call, but yeah, if we were to exit this, we'll see that the Python version is 3.9. All right, so let's re-import TensorFlow and verify that that's here. Okay, so with this in mind, what we can do, let me see where our screen went. All right, we still have this node here. So we're gonna try to define them, like to use the logic that this encode function really uses on the Google Colab notebook. It's just like this strings as string. Okay, so the first thing, let's actually define here our tensor. So if I have a tensor, I can do tf convert to tensor, and we can say, okay, my tensor is going to be 1, 2.345, and then 1000,005, right? This is just a list of numbers, and when I enter, let's just do that once again so we don't get all that appears the first time I execute something. And then I click, and this tensor is actually of shape 3, so it's just like a one-dimensional, float 32, has a numpy array, and the d type is float as well. Okay, so we could do, for example, tensor.numpy and just get that array. We could actually get this back to a list with the list method. And because it's a float, this is now parsed into 1.0 instead of just an integer, right? If we did something like this, tfcast tensor, and then the d type would be tfint 32, for example, we actually get the numbers to be 1, 2, and 10,000 instead of what our tensor has, that is like 1, 2.345, and 1,000, so 10,000.005, as we could see here, right? 10,005. All right, so we do have then our tensor variable, and what we can see in that method is that the TIFF strings model from TensorFlow v2, we can have this, we can call this method on something, and in this case we're going to call it for our tensor, and we're going to get that as a string. So you see here there is like this binary 1.0000. It's actually adding 3 zeros here to each of them, so you can see the precision here takes this number down to 004883, which is 005. And yeah, so let's see if we just do here a list from this tensor. Let me see if I can break it. Okay, so we get these binary strings. And what's interesting is that we are, if we do tensor as strings, right, this could be our encoded, let's say, result, we could now go the other way around to decode it, which is with TensorFlow strings to number. So TF strings to number, and then put here the tensors as strings. And now we're getting those numbers. And let's see if we, with NumPy, we just get like a list of numbers. And we actually recover back the result of what we had before, right? So let's go once again. What we get is a float here with the same variables. So in a nutshell, what we've done here is that we have encoded and then decoded. So for this encoding, so if I put here the encode was just this TF strings dot as string. I think that was it, right? Like if I go back, it was as a string tensor, right? So as a string, and then here our tensor, and then the decode step was TensorFlow strings as number, and then X, which, you know, could be the result of this in here. So we encode and decode. We go from, let me go back. So there we go from float to string to float. And this is encode. And then this is decode. Okay, so now that we have this clear for this really simple example and we know how to do it and that it works with TensorFlow, we can understand these functions. And what's going on here is that this model has these two methods, encode and decode, and they're decorated with the input signature type being a float 32 here and string here, which we have seen in our example. So in the signature wise, the above TensorFlow model can be summarized as follows. The signature, and the signature is key encode, input X, output encoded result, and then the other one is decode X and decoded result. Right, so this is what we just saw. Convert a model with signatures. TensorFlow Lite converter APIs will bring the above signature information into the converted TensorFlow Lite model. This conversion functionality is available on all converter APIs starting from TensorFlow version 2.7.0 from save model. Okay, so we haven't executed this, so we're gonna define the model class. And in here, what happens is that we instantiate a model variable in Python calling that model class. So we save it to content save models coding, TensorFlow save model save this model to that save path. So the model defined here goes here, the save model path goes here, and then the signatures, model code get concrete function, decode get concrete function. Okay, and then we convert the save model using TensorFlow Lite converter to TF Lite converter from save model path, target spec, support operations, TF Lite built-in, select TensorFlow, enable TensorFlow Lite ops, enable TensorFlow ops. And then the TensorFlow Lite model is converted, and then and will be okay. And I guess this is not being saved, but it could be also saved. So, okay, so let's do one thing. So we're gonna run this and we're gonna go into full screen mode because here I can see the content, save models, coding. And this is the, so this is the format of a save model, right? So we have the assets, nothing here, the variables, and the save model PB. And we are feeding that path, so this coding folder, into the the TF Lite converter that is going to load the model and then see the supported operations. So set the supported ops and then convert the model. And then we have that interpreter, and we see that we have the decode and output decoder result. If we were to do this with a Keras model, it would probably have the serving default TF model operation or signature. So let's actually save this model. Let's actually see if we go here to the converted, so TensorFlow Lite converter. Okay, so so it seems now they have 211. Let's take a quick look. TensorFlow. The 211 is the latest official released 4 days ago. So that means that that's probably what we're gonna get installed by default when we okay, cool. All right, so let's take a look here. Okay, convert TF Lite models, hide this, and I'm still really just looking for this. So with okay, all right, so we are going to do this. So with model.tflite, right, as f, right, and this is the TF Lite model. I think that's it, right? Open. Okay, so we gotta open that here. So with open TF Lite, so we define the path that we're gonna save here, writing as file write, and we write that. All right, so we'll do this. So it's gonna convert the model again and save it. And now here we get this model TF Lite. I can go ahead and download that, and we can open this with Netron. So Netron is the viewer, and we see this is really simple. So we just have these two operations. It only shows decode. I'm not sure why. Subgraph. Okay, decode and encode. Decode, flex a string to number. So decode a string to number. You can, I'm not sure, I cannot zoom in here. Okay. So decode takes a number and converts from string to number, and then we get the output as a flow32. This is, you see the types there, so string, and then here flow32. And if we go to the encode one, we're getting a flow32 flex as a string, and then getting a string back. Okay, that is a really simple model. Let's see if we get a quote unquote real model, what happens. Let's see, let me try here. If we just do okay, so they're actually doing it in here, so we don't really need to define it. I wanted to do like a sequential model, and you're gonna see the serving default, right? Yeah, so the serving default is the default signature that we have there. And I guess we could also add custom signatures to another model. That would be really interesting if we have both of them. If we have like a model maybe that contains a few like multiple models or different things. And hey, I'm here seeing Sajay Kumarji online. Hi, long time no see. I'm super glad to see you online. I know that this time works a lot better in India. I would love to hear what have you been up to? What are you up to lately, and what projects are you working on, or what are you looking at lately? All right, so if we save this model, so with open model keras TF Lite as F right, and then we do here the TF Lite model again. We're gonna get this model saved in here, and now if we open it with Netron again, we're gonna see the different layers of this model. So here we're taking a float 32 with 1,4 shape. So let's see what that is. Yeah, okay, so it's like a dense layer of 4 digits, and we're getting here a fully connected layer, relu, and then we get the output. There's going to be a float. It's just going to be one number. And I guess this TF Lite model gets signature list. We have input, X input, and outputs. Okay, so if we go here to run signatures, load the TF Lite model in TF Lite interpreter. Signatures interpreter get signature list. So what we're gonna do here is we're gonna put the path here to the TF Lite model. So TF Lite model is gonna be model.tflite, and that's gonna load this one. Let's see if that runs. Oh, model content. Okay, so I guess it's not the path. Okay, so TF Lite interpreter, because I want to model path. Okay, so we just need to change here model path. Okay, so we see we're loading now decode, and another thing that I see here that is slightly different than what we've done before is that we can do TF. So this is TF Lite interpreter, and then we can do from model path, and then like a file path, or model content, and then we do here a model object. Okay. Okay, here back to suggest comment. So he's talking on the chat. So let me go here. How can I pop the chat here? All right, so these loads, not sure. Yeah, so here, Sajay is saying that he's been slightly busy with a new job, head of design, I guess, at a design and fabrication lab. So doing a lot more robotic fabrication, a lot of projects, and a lot of teaching. That's pretty awesome. And what are you teaching? I'm curious. He says that the only drawback to his new job is that his odd work hours keep him from catching the live stream. Yeah, that's awesome. I mean, it's okay. It's good to know that you're still around. Yeah, I'll encourage you to like the video if you're want to support the channel. That really helps. Okay, so great. So we have recorded those two methods, so two different ways, right? If you've defined them, if you've already converted the TF Lite from the TF Lite model from another model that you loaded and you have it in memory as an object, you can simply feed it into the interpreter to interact with it, right? So here we are interacting with a model that we've loaded from file that we actually saved. And that would just mean changing this to model content if you have the variable defined in there. So we see the signatures, so we can list the signatures of the model, decode. Okay, and then we get the input tensor, so 1, 2, 3. And then, okay, so here we can simply get the signature runner, which is, I guess, is just a function. All right, that's pretty cool. Okay, so here we do, yeah, I mean, this is giving us the same results that we saw before, right? Like encoded, stringified, and then this is back to normal. So I guess I could, here, I could simply do encode, one. Let's make this a lot bigger. Encode 1, what we had before, 005 and 2354 345 encode. All right, we need, so these are named arguments, so we put the x there. How are they doing? Input, okay, and it needs to be a tensor, so tf convert to tensor. At least this is what we were doing before. I'll see what they're doing in this example. Okay, so now encoded result b blah blah blah. All right, so encoded, we get like a JSON object, so we could directly get that from there. TF constant. Okay, so they're making a constant instead of a tensor. So does this work the same way? TF constant. Yeah, same way. And you know, we could just say here encoded result. No scalar. How are they getting it? Encoded. Right, so we get that one more level out. So you see it. I just moved this out from inside here, so that should work now. Okay, so now we have that array, and as I said before, we could get that back as a list by doing this, but what we're gonna do is we're gonna decode it back, and we're gonna say x is here, so we're gonna get the decoded result, and then we'll just put here decoded result. So we're encoding this and then getting it back at where we had it. So let's actually break this down a bit so it's easier to see it. Okay, and I guess the last thing, so if this is working, the last thing we could do is just make this into a list, and we get back what we input. So we're encoding, getting the result, decoding, getting the result, and making this into a list. And then this is like a round trip between, so encode, decode, round trip. And we encode the data and we get it back in the same way. All right, once more, taking a look at what Sajay is saying on the chat. He's saying that he teaches robotics and fabrication workflows, electronics, and C programming for IoT, the Internet of Things, Blender and visual programming, Grasshopper, and Touch Designer. This is awesome. I think maybe we should get together on a call at some point and see if there's something that we could prepare for you to share on the live stream. I'm actually thinking that for live stream number 100, or like to celebrate 100 live streams or something, we could have different people share things that they know in the channel for the audience, and that would be like people from the community that want to share things. That would be a really good effort if we get it, but yeah, let's see. All right, we're running out of time here, but we understood what this does. And the one thing that I would love to do and try to see um, is see if, these functions are actually so much faster than Python, right? Like if the code is running inside of TensorFlow instead of just plain Python. But we're not going to do that right now. We're just going to keep going. So another question I have is, would we be able to embed, so to add one of those signatures to one of these models, right? So this is TF sequential, and I'm not sure. Can we subclass sequentials? Like, can we add TensorFlow signatures to Keras model? Save model signatures. TF Keras save model signatures. This drops the trained Keras model into serving function that can be saved with and loaded with corresponding signature. The regress save model signatures. Content feature, spec example feature, mass feature. Define signature, regress, and predict service. What is the purpose of this? Sequence also of models. Serving default specifies regress or predict as the serving default signature. Oh, okay. I had this advanced article here that we didn't take a look at. We could, maybe in the next lecture, I could take a look at this. Okay. If you're already familiar with this and TF function, you should check out the introduction to graphs and functions guide, saving model layers and model guide. With a graph, you have great deal of flexibility. You can use TensorFlow graph environments, don't have a Python interpreter like mobile application, but device and backend services. TensorFlow uses graphs as the format for save models when it exports them from Python. So, okay, we are on time. Okay, we're on time. So this is discount time. We need to learn more about graphs, so we're gonna take this for next stream. So let me put this here, and maybe also this one. We're commenting here on community live stream. Sounds like a great idea. This is suggest. So we are talking about the possibility of having the audience also contribute. From a code standpoint, functions decorated with TN function create a Python callable. In the documentation, we refer to these as polymorphic functions, as they are Python callables that can take a variety arguments signatures. Each time you call TF function with a new argument signature, TensorFlow traces out a new graph just for that set of arguments. This new graph is then added as a concrete function to the callable. Thus, a safe model can be one or more subgraphs, each with a different signature. Safe model is what you get when you call TF save model safe. Safe models are stored as a directory on disk. The file save model PB within that directory is a protocol buffer describing the functional TF graph. In this blog, we take a look inside this protocol and see how function signature serialization, deserialization works under the hood. You'll have a greater appreciation for what functions and signature before, which can help you load, modify, or optimize safe models. Okay. All right. So my two questions I need to answer. The idea that I would like to dig in is whether we can make a keras model, for example, that also includes other operations, or if we have to have two different models for example, data preprocessing or other operations to manipulate data. So yeah, it was Nono Martinez Alonso here. Thanks a lot for watching, for being there, for joining. Leave some comments if you have them, if you have questions or comments of things that you would like to learn and see. I would encourage you to like the video to support the channel and let me know that you're liking this content, and to subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. Once again, it was Nono Martinez Alonso here. You can join the Discord community at nono.mas/discord. I'm here to serve you and to teach and to hopefully bring you things that will make you learn. Thanks a lot for watching, and I'll see you next time. Bye.